Hi everyone, and welcome to this new video. Today we are going to continue talking about the geometry. In that specific case, we are going to talk about the triangles. The last class we saw the classification of triangles. Remember that we classified the triangles according with the angles, internal angles, and according with its side's longitude. In that case, we also saw the formulas to calculate the perimeter and the area. Today, I'm going to talk about two different classifications, but that classification is going to be related with the theorems that you need to use. I mean, the mathematics tool that you need to use in case that you have a problem when you need to work with a triangle. Triangles is a very important topic into the geometry because it's the base of the geometry. A lot of the geometric shapes are going to use triangles because the triangles are going to be implicit on. For example, if you have for example a polygonal with whatever number of sides, you can find some triangles implicit form inside of. Okay, so let's start with that classification. In that case, I'm going to classify the triangles in two different kinds of triangles. I'm going to repeat that this classification is absolutely different with the classification of the last class. Okay, the first classification of the triangle that I'm going to talk about will be the right triangle. And what is a right triangle? We talked about that the last class. Right triangle is a triangle with one internal angle of 90 degrees, like that one. Okay, so this is the first one. And the second one will be a triangle called oblique triangles. And what is an oblique triangle? It's very easy. Oblique triangle will be whatever triangle that is not right. So, for example, this could be an oblique triangle. Remember, this is not about the last class classification. This is absolutely different. If the triangle has 90 degrees internal angle, it's going to be called right triangle. But if the triangle has not 90 degrees internal angle, it's going to be called oblique. So we are going to divide the triangles in right and not right, or right and obliques. All right? Okay. Now, what I'm talking about that, it's because at the time that you want to solve one problem, when a triangle is involved, you need to know the theorem that you need to use, and not all the theorems are used in all the triangles. For example, here I'm going to make another sub-classifications, and I'm going to talk about two different cases. For example, look at this. Here I'm going to, let me show you, I'm going to draw a right triangle, and here I'm going to draw again another right triangle, and I'm just going to make one difference. The difference is this. Can you see it? What is the difference between this and this? Well, the difference here is that I only have a right triangle, and maybe I know the sides of the triangles. But here, in additional, I'm going to have one more information. That information is this angle. So in that case, I'm talking about two different cases. Okay? First of all, let's talk about the names of the sides of the right triangles. This longest side in both triangles, it's called hypotenuse. All right? So let's write over here H from hypotenuse. Now, what about the other sides? The other sides are called cathetus. But in that case, I'm just going to talk about cathetus and cathetus. Alright, that's all. But here the cathetus are going to have an extra name. I mean, this cathetus is going to be called not just cathetus, it's going to be called adjacent cathetus. Why adjacent cathetus? Because here I'm talking about an angle, and this angle is made by the hypotenuse and the cathetus. In that cathetus that is forming the angle is called adjacent. In that case, this one that is in front of the angle corresponding that I'm talking about will be called opposite cathetus. Okay, so this is the difference. If we work with that kind of right triangle where we know only the cathetus length or longitude and the hypotenuse, we are going to use the Pythagoras theorem. In that case, what the Pythagoras theorem says? Well, it says that the square of the hypotenuse is the same, or it's equal to the addition of the square of each cathetus. Alright, so we're going to add the square of each one, and this is going to be the same of the square of the longitude of the hypotenuse. But in that case, when we are going to use some right triangle but with a reference of what angle, or we want to calculate an internal angle, we are going to use a trigonometrical identities. Which one? Well, we're going to have in specific three principles. The first one is going to be, let's suppose that we're going to call to this angle, we're going to call theta. Remember, theta is a Greek letter that represents an angle. Okay? So in that case, the first one is going to be the cosine. The cosine of theta could be calculated by the division between the adjacent cathetus over the hypotenuse. The next one is going to be the sine. The sine of the theta is going to be calculated with the division of the opposite cathetus over the hypotenuse. And the last one is going to be the tangent. And the tangent is going to be calculated through the divisions between the opposite cathetus over the adjacent cathetus. Okay, so this is the information that we are going to need to work with that kind of right triangles, and this theorem is going to be worked with that kind of triangles. You want to know about the angles? Use this part. You only want to know about the lengths and the only information that you have at lengths? Use this part. Alright? Okay. So in that case, we finish with the right triangles. Now let's continue with the oblique triangles. With the oblique triangles, we are going to make some specific classification. Look at this. First of all, you are going to label the internal angles with capital letters. For example, this angle I'm going to call A, this one is going to be called B, and this one is going to be called C with capital letters. Now, the opposite sides of the side that is in front of the angle is going to be named with the same letter but not in capital letters. For example, for this angle, the opposite side that we have is this one. So this side is going to be called B. Sorry, A. Okay? This is the V angle, so the side that is in front of this one is that one. So this one is going to be B. And finally, if this is C angle, the front side is going to be this one, and this is going to be called C. Okay, it doesn't matter which one do you decide to be A, B, or C? It doesn't matter, okay? But remember, the angles will be labeled with capital letters, and the other ones with not capital letters, okay? Well, in that case, according with the information that we have, we are going to have two options to work with. The first option is going to be the law of cosines, okay? And the law of cosines is going to be the next formula. For example, if you want to calculate the side A, well, in that case, we are going to calculate A squared is going to be equal to the other side, B squared plus C squared minus twice B times C times the cosine of the angle A. Okay? It's going to be the same if you want to calculate B. For example, over here you can write B squared is equal to A squared plus C squared minus twice AC times cosine of B. Or if you want to calculate C squared, well, in that case it's going to be A squared plus B squared minus twice AB times the cosine of C. Okay, we have that options, right? And the other one, well, I don't have enough space over here, but I'm going to continue over here. Okay, it doesn't matter. Well, the second option that I have to work with oblique triangles is going to be the law of sines. And the law of sines, it's just a reference of, let me separate over here, let's separate it, we're not confused. Okay, it's just a reference between proportions. For example, A over sine, sorry, in that case it's not A over sine of A is proportional to B over sine of B, that at the same time is proportional with C over sine of C. Okay, this is the law of sines and this is the law of cosines. Law of cosines and law of sines are going to be used only with oblique triangles. Trigonometrical identities and Pythagoras theorem are going to be used only with right triangles. And if you talk about only longitudes of the sines, you are going to use only Pythagoras theorem. Or if you want to calculate one internal angle, or you have as an information an internal angle, use trigonometrical identities. Okay, so we have specific things and specific mathematic tools according with that kind of triangle. Remember, we have right triangles or not right triangles that will be called oblique triangles. The first example will be about right triangles. In that case, in letter A, we have a triangle with two length information. The hypotenuse is 50 centimeters length and one catetus is 20 centimeters length. In that case, I want to calculate the perimeter and area. Remember, first of all, the perimeter formula. Remember that in the first class we saw that the perimeter formula is the addition of each side of the triangle. Okay, like in that case. But we have a problem over here because we don't know this longitude about this side. Okay, so we need to calculate it. the question is, what are we going to use? Are we going to use the Pythagoras theorem, or where are we going to use a trigonometrical identity? Remember that in that case I'm talking about the right triangle. Well, if I only have information about the lengths, so it means that I'm going to work with Pythagoras theorem. The Pythagoras theorem says that the square of the hypotenuse is going to be the same of the square of the one cathetus plus the square of the second cathetus. I'm just going to label 1 and 2 just to make a difference. In that case, this is going to be the hypotenuse, this is going to be the cathetus number 1, and this is going to be the cathetus number 2. Okay, so it doesn't matter if this is 1 and 2, it doesn't matter. So now we are going to make a clear process, because I have that information and I have this information, but I would like to know this length. In that case, what I'm going to do, okay, first of all, this cathetus that is adding is positive, I'm going to pass to the other side, and then I'm going to have the square hypotenuse minus the first cathetus square. It's equal to square of the second cathetus. All right, but I don't need the square value, I need the value in linear. So how can I disappear these two? Well, according with the clear process, I'm just need to use a square root here and a square root here. Why in both sides? Because I need to keep the equilibrium of the equation. Okay, in that case, I'm going to eliminate the square with the square root, because those are an inverses operations. So at the end, I'm just going to have the square root of the square hypotenuse minus the square of the cathetus, and this is going to be this cathetus 1, this is going to be cathetus 2, and this is going to be the clear formula. Okay, so the only thing that I need to do right now is just to use this kind of information, and then I'm going to have this value. Okay, so cathetus number 2, that is this one, or you want to call instead cathetus 2, you want to call x, because this is x side, it's equal to the square root of 50, in that case is 50 centimeters square, plus, sorry, in that case it's not plus, it's going to be minus the first cathetus length, that in that case is going to be 20 centimeters square. Okay, so right now we need to make that operations. How much is 50 squared? So we can take the calculator, okay, and then we're going to use 50 square, and this is going to be 2,500 square centimeters. This is very important, square centimeters, you need to use the unit. And the other one will be 20 square, and it's going to be minus 400 square centimeters. Okay, so now we are going to make the subtraction of 2,500 minus 400, that is going to be 2,100 of square centimeters. Okay, well, this is going to be the length of the side, but we need to get the square root of that. But look at this, if I made the square root of the answer, and look at this here, I'm going to have a simplified form of that one, because this is an irrational number. What is an irrational? That is not an exact root. So this is going to be approximately 45.82, 57, 56, 95, etc. In that case, if you don't want to have a mathematical error because of the quantity of the decimal that you can miss in the process, you can do only use this 10 times the square root of 21, that is another form to express this one, or even you can say that this is going to be just the square root of 2100, but just centimeters. Why this is going to be outside? Because the square root of centimeters square will be just centimeters. Okay, so this is the length of this side. Well, and we use the Pythagoras theorem. So now I can calculate the perimeter, and I can say that this is going to be 50 centimeters plus 20 centimeters plus, instead to use this one, 45.82, etc., etc. What are we going to do? We are going to use the square root of 2100 centimeters. Okay, now the final result, look at this. In that case, I'm going to use this one. I'm going to say that this is going to be 50 plus 20 plus the square root of 2100. Okay, well, the calculator is going to give me a simplified form, but in that case, at the end of the problem, you can use with decimals, it doesn't matter, but just at the end. In that case, as you can see, I cannot say that perimeter is equal to 115.82 centimeters, because this is not true. It's 115.82 centimeters, but 82, 57, 56, 9, etc. So in that case, what I'm going to do, I'm just going to add here a symbol that represents approximately equal. Okay, and this is going to be the perimeter that we are going to write over here. So perimeter is approximately equal to 115.82 centimeters, and that's all about the perimeter. Okay, so let's remember what is the area formula for the triangles, and this is going to be very easy because it's base times the height over 2. Okay, so let's see what is the base of this triangle. In that case, remember that the base and the height should be at 90 degrees both. So in that case, I just have with 90 degrees sides this one and this one. So right now I can say that this is going to be the base and this is going to be the height. And the only thing that I'm going to do is just to apply the formula, and I'm going to say the area is going to be the base, that is 20 centimeters times the height. The height is going to be the side length, that is how much? Is this one, times the square root of 2100 centimeters over 2. Okay, and let's do it. Let's take calculator, and then I'm going to write the 20 times the square root of 2100. Okay, sorry, in that case I need to put it the parentheses outside of the square root over 2. And well, in that case I'm just going to have another irrational number. Remember, irrational, we have infinite number of decimals. In that case, what I'm going to do, I'm going to write again that is approximately equal to 458 point, and I'm just going to take two decimals, 20, 25, and the units will be centimeters times centimeters will be square centimeters. Okay, and this is going to be the area. Here I'm going to write it, and it's going to be approximately equal to 458.25 square centimeters, and it was the first example of right triangles. Now let's continue with the second example. Here we need to calculate the perimeter and the area of that. Here we have different information. For example, here I have length of one cathetus and one angle. In that case, I'm talking about that this one should be the hypotenuse, okay, and this one will be a cathedus, but not just a cathedus, simple. It's going to be a adjacent or opposite cathedus. So my question is, what kind of cathedus is that? Is opposite or is adjacent? Well, if this longe in front of this angle, it means that this is going to be the opposite cathedus. So it means that this one will be the adjacent cathedus. Okay, and obviously this 40 degrees will be theta. Okay, it means that to get this length and this one, I'm not going to use Pythagoras theorem. Because why? Because I have an angle, and an angle is part of the information. So here I'm going to use a trigonometrical identity. But remember that I have three. I have, the first one is the cosine of theta, that is adjacent cathedus over hypotenuse. I have sine of theta, that is opposite cathedus over hypotenuse. And I have tangent of theta, that is going to be the opposite cathedus over adjacent cathedus. So my question is, which one I'm going to use? Well, it depends of the information that you have. For example, you have what? You have the angle. Well, we have angle here, here, here. So we can use whatever of these three. But I have the angle, and in additional I have the opposite cathedus. So look at this. In which one do you have angle opposite cathedus? Well, in that case I have two options. It could be sine or it could be tangent, because sine has opposite cathedus and the angle, and tangent has opposite cathedus also and the angle. If I use sine, it means that I can calculate the hypotenuse. But if I use tangent, it means that I can calculate the adjacent cathedus. So in that case, I'm going to use both. Okay? Okay, first of all, let's work with this one. Let's work over here. I'm going to write sine of 40 degrees. So I'm substituting the measure. Okay? It's equal to, in that case is opposite cathedus, that we know that in that case is 5 centimeters over the hypotenuse. Okay, so what we should do over here, we need to clear this one is dividing, so you need to pass how? You need to pass multiplying, and then you are gonna have, let's write over here, hypotenuse times the sine of 40 degrees is equal to 5 centimeters. But now I need to clear hypotenuse. So what I'm going to do here, I'm just going to let hypotenuse alone, and this sine that is multiplying is going to pass how? Dividing, and then it's going to be 5 centimeters over the sine of 40 degrees. So it means the hypotenuse is going to be equal to, now let's see. Well, first of all, if we are going to work with degrees, because the angles could be measured in degrees or it could be measured in radians, you need to check your calculator over here in the screen that you need to have a letter D of degrees. If you are not on, so the thing that you need to do is just to switch the angle unit. In that case, in that kind of calculator, is shift menu number 2, that is angle unit, and select number 1, that is degrees. Okay, and here you are going to have a little D. Okay, in your calculator it could say DEG, all right, of degrees. Well, in that case you can use it. Now I'm going to calculate 5. Well, it's going to be a division 5 over the sine of 40 degrees. Okay, and this is going to be 7.7786. Look at this. In that case, we are not going to have again, look at this, we are not going to have again an exact number. We are going to have an approximately number. Okay, so I'm going to show you one thing that you can do it to avoid that kind of mathematical error. Look at this. We can say that this is going to be approximately equal to 7.77 centimeters. You can say that for one way, or even you can do another thing. You can save that exactly number and use it later. How? Very easy. Exists one key in your calculator that is called STO. STO means storage, and then the storage is going to activate the application that you can save the entire number here in your memory. I'm going to show you how to do it with this kind of calculator. Okay, you need to pay attention because I'm going to still using in other examples. Okay, so this is a thing that I'm going to use very frequently, and I need that you pay attention about that. Okay, you need to do it again. Let's do it again for the beginning. I mean this one. Okay, I'm going to make 5 over the sine of 40. Okay, and then I'm going to have the operation and the result. You need to press the key AC, and it's going to disappear off the screen. Alright, now you are going to press the key answer, and then you are going to have just answer and equal. When you have answer and the final result, in that moment will be the moment to storage the data. Look at this. What I'm going to do here, I'm just going to press this key STO, storage, and then select one letter that we have over here. It's like purple letters: A, B, C, D, E, F, X, Y. Okay, just select one. In that case, I'm going to select A, and look at this. Here say answer, and then an arrow and an A. It means that this one H is storage with the letter A in my calculator. So when I want to use it again, let me move a little bit this one to have a clearest, yeah, here we have a clearest vision. Look at this. If I select alpha and then A, can you see it? Alpha A, and then press equal. Look at this. I have this one. This datum is inside of the memory. Okay, well, now if you have a calculator like this one, it's going to be something similar but kind of different. Look at this. I'm going to do it again. This one, first of all, I need to check that it should be on degrees. To press only mode, and then at the second time that you press mode, you have degrees, radians. Okay, degrees, select degrees, select 1, and here you will have the letter D. Okay, well, in that case, I'm sure that it is in degrees, and I'm going to work with. Now, this one I'm going to do it again. It will be 5 over the sine of 40. Okay, I'm sorry. So it's going to be equal. Here we have the operation, and here we have what? The result. Remember, press AC, and then press answer, and then equal. You will have the word ans and the result. Remember, this is very important. Ans and result, not operation and result. Okay, so that's why you need to press AC and then answer. Well, in that case, the storage key is not going to be activated directly like in this calculator. Look at this. This calculator is directly, but this one not. You need to use shift to activate it. Okay, so you are going to activate a shift and then this key that say RCL, and then select A, B, C, D, E, F, whatever. So in that case, you're going to select A, and then you have answer arrow A. So it means that it's inside of your calculator in the memory, and you can check it. Just disappear it and select alpha A. Can you see it? Like this one. Right now, alpha A. Can you see it? So it means that I'm going to have exactly the quantity of the hypotenuse length, not the approximately. Maybe this part I'm just going to use it for information, but I'm going to be sure that the exactly length of the hypotenuse will be stored on A in my calculator. Okay, so let's continue now with the tangent, because I'm going to continue over here because I want to calculate the adjacent cathetus. Okay, so what I'm going to do, I'm going to use the tangent of, in that case the angle is 40 degrees, is equal to opposite cathetus, that is going to be what? 5 centimeters over adjacent cathetus. You know that, well, I made here step by step the clear process, but it could be very easy. Just this one that is dividing is going to pass multiplying, and this one that is multiplying is going to pass dividing. So at the end I'm going to have AC is equal to 5 centimeters over the tangent of 40 degrees. Okay, so the adjacent cathetus will be, look at this, let's take the calculator again, and then let's do it this operation like a 5 over tangent of 40, irrational number. So it means that this is going to be approximately equal, all right, approximately equal to 5.95 centimeters. Look at this, it's very important that you put always the units, in that case centimeters, but I need that entire number, that irrational entire number, in my memory, because I'm going to calculate perimeter and I need the real numbers. What I'm going to do, easy, AC answer equal storage B. Okay, and you can verify it that on B you have right now this number. I'm going to write over here B. Okay, so if I continue with my problem, I can say it here with a parenthesis that is going to be A, and this is going to be B according with my calculator. Okay, and then I'm just going to calculate the area, sorry, the perimeter, that everybody knows that is the first side plus second side plus third side. Okay, so in that case the total perimeter is going to be, look at this, L1, I mean this, and this. What I'm going to do is very easy. I'm just going to write first of all this one 5 plus, then this one that is whom, A, alpha A, plus this one, who is this one in my calculator, B, plus alpha B, and this is going to be approximately 18.73 centimeters. So right now I have the first result that it will be 18.73 centimeters, and right now we are going to calculate the area, and the area is going to be base times height over 2. Who is the base, who is the height? Remember, base and height should be always at 90 degrees. So in that case, I'm going to say that this one will be the base and this one will be the height. Why? Because those are at 90 degrees. Okay, and just I'm going to calculate the area like B base, that in case is 5 centimeters times the height. Who is the height? Is the adjacent cathedral, that in my calculator is b, over 2. And this is going to be, let's calculate it, is going to be 5 times alpha b over 2. It's going to be approximately equal to 14.89 square centimeters, and here I'm going to write 14.89 square centimeters. Okay, and it was the example letter A and letter B of right triangles using Pythagoras theorem and trigonometrical identities. On example number 2, we are going to work with oblique triangle. In this case, we have a triangle with two sides, one of 4 centimeters length and the other with 8 centimeters length, and with an angle of 110 degrees. We are going to calculate the perimeter and area. First of all, to calculate the perimeter, we need to know this side length. So the thing is how we can do it. Right now we cannot use the Pythagoras theorem or the trigonometrical identities. We need to use, remember, the law of sine or the law of cosine. Well, the first thing that we should do is that we need to label the internal angles and then the sides with internal angle with capital letters. In that case, this is going to be A. I'm going to put it over here, and I'm going to say that this is going to be B and this is going to be C. According with that labels, it means that this side from here to here length is going to be A, because this side is in front of this angle. This one of 8 centimeters is going to be B, and this of 4 centimeters is going to be C. Okay, well, remember, if you want to calculate it with law of cosines, the formula is going to be, for example, in that case, I want to calculate A, is going to be A squared is equal to B squared plus C squared minus twice BC cosine of A. But I don't want to calculate A, so what I should do to eliminate these two, use only a square root over here and the square root over here. Here the square root with the square are going to be, both are going to be eliminated, and then finally I'm just going to have A. Okay, so let's see if it is possible to use this formula. V squared, well, the datum B, do we have? Yes, we have it. C, yes. And A, yes, we have it. So it means that we can use this law of cosine, sorry. What about if I pretend to use the law of sine? In that case, it could be a relation of proportions. For example, A, that is the side that I'm interested on, over sine of A should be proportional to B over sine of B, and is going to be proportional also with C over sine of C. For example, A, we don't have it. It's the one that we want to calculate it. A, capital letter, we have it. Okay, this is the data, we have it. V, we have it. But B, capital letter, we don't have it. So it means that I cannot use this one. In that case, C, I have it. But C, capital letter, I don't have it. I cannot use this one. So it means that I cannot use the law of sine. In that case, I'm going to use the law of cosine. Okay, so let's substitute the data over here. And V is going to be 8 centimeters squared plus C, that is 4 centimeters squared, minus 8 centimeters times 4 centimeters times the cosine of the 110 degrees. Alright, so here we have how to calculate A. Okay, let's use our calculator, and I'm going to put it the square root of, open parentheses, 8 close parentheses square, plus 4 close parentheses square, minus open parentheses 8 open parentheses 4 cosine of 110. Remember, they should be in degrees. Okay, and this is going to be equal to 9.5364. So this is going to be approximately equal to 9.53 centimeters. Here we have centimeters square, square centimeters, centimeters by centimeters is centimeter square, centimeters square, centimeter square, centimeter square with the square root, it will be centimeters at the end. Okay, but I'm going to storage this number, my calculator, because I need to calculate perimeters and I need to be the more exact possible. In that case, I'm not going to use A, B, or C, because I don't want that confused with the information that I have here in the triangle. So I'm going to use D. All right. So remember, it is AC. Answer equal. Then storage and D. Right now it's storage on D. Let's see if it is. Yes, it is. Okay, so this is going to be D. I'm gonna put that information over here. You have calculator, not like this one. You have calculator like that one. So you need to be very careful when you introduce this data on the calculator. My suggestion is that, for example, here it's possible to type everything like here, exactly like here, but here not. My suggestion is first start with the inside information and then apply the square root to the answer. Look at this. Use parentheses 8 squared plus parentheses 4 squared minus parentheses 8 parentheses 4 cosine of parentheses 110 close parentheses equal, and that one apply the square root to the answer, and then you will have the same like that one. Okay, so be careful. And here the same thing. AC answer equal, in that case is shift here or RCL, but the shift storage and letter D. Okay, we have right now on letter D. Good. Well, let's continue. Right now we are able to calculate the perimeter. Perimeter, remember, it's side 1 plus side 2 plus side 3. I'm talking about lengths. Okay, so this is going to be equal to, well, this one, the first one is D. Why D? Because I have my calculator like D, plus B, in that case is 8 centimeters, plus C, that in case is 4 centimeters. Okay, okay, just let me erase over here 8 centimeters. So let's calculate it. I'm going to show you. Alpha D plus 8 plus 4. Then we are going to have approximately equal, sorry, it's not beautiful design, approximately equal to 21.53 centimeters, and this is going to be the perimeter. Okay, let's write it over here, 21.53 centimeters. Now we need to calculate the area. Remember, the area formula is base times the height over 2. Okay, look at this. This is something important. In the last example, in the other examples, we use this side like a base. So I'm going to write over here base, and the other side was taking like a height, but in that case this side of 4 centimeters is not going to be the height. Why not? Because the height and the base should be at 90 degrees, and as you can see, it's not a 90 degrees, it's 110 degrees. So if we make, well, if we extend the baseline like that one, and we make a line of 90 degrees, I mean a perpendicular line, look at this, we are going to form a 90 degrees, and it means that this line, then I'm going to put it with other color, this one is going to be the height. Okay, so what we should do, well, look at this. Here I know that we are working with oblique triangle, all right, but look at this. Here we have an external right triangle, so all of this, can you see it? I know that this is not part of the triangle, it's implicit, it means that it's not part, but we can build it outside of. And look at this, I'm gonna put it over here, and I'm gonna put the information that I have for that. In that triangle I have next information. First of all, this side length, I know how much is that. This is the hypotenuse, all right, that is this one, and I know it's 4 centimeters. Okay, the other thing that I know, not directly, is this angle, that is this one. Remember, what is the name of this angle? With this angle plus this angle, they are going to form 180 degrees. In that case, this angle is the supplementary angle of this one. So how much is that one? In that case, it is going to be of 70 degrees, because 110 plus 70 degrees, we are going to have 180 degrees. Okay, and this is going to be the height, and the height, according with this triangle where I have an angle, what kind of cathetus is that? Is opposite cathetus or is adjacent cathetus? In that case, it's going to be an opposite cathetus. Alright, so I have that information. Here we are going to use again a trigonometrical identity. Which one? Sine, cosine, or tangent, where I can use the hypotenuse, the opposite cathetus, and the angle. Here I need to use the sine. The sine of the angle, it's equal to the opposite cathetus, in that case is the height, over the hypotenuse, that in that case is, I'm going to put it a capital letter for not be confused, this is h, okay, this is h, over the hypotenuse, that is 4. Okay, so we can clear it, and we can, this one we can pass it multiplying, and we're gonna say that 4 sine of theta is equal to h, and h is height. So it means that height is how much? Okay, let's work over here. Well, this one is going to be 4 sine of well, in that case the theta is 70. Okay, let's put it here, all the information. Okay, sine of 70, sine of 70. Okay, well, it looks like a weird. 4 sine of 70 degrees is equal to h, okay, to the height. 4 sine of 70 is equal to approximately, look at this, approximately equal to 3.7587 centimeters. Okay, so this is the height of the triangle, is the distance that exists from the top of the triangle to the base at 90, like a parallel, like a perpendicular line at 90 degrees of the base. Okay, so we can use directly here the formula of the area, or if you want, you can storage like AC answer equal, and then storage like E. Okay, there we go. I have it. Let me check. There we go. So this is going to be E. It's information that I need. Good. Okay, with that information, I can calculate the area. Area, it's equal to base. Well, how much is the base? The base is 8 centimeters times the height, that is E on my calculator, over 2. So area is going to be, let's do it, A times E over 2. It's going to be approximately equal to 15.03 square centimeters, and this is going to be the area. Let's put it over here, 15.03 square centimeters. All right, and it was the first problem of oblique triangle. On letter B, we have another oblique triangle. The information that I have is one length side and two internal angles. Okay, so the first thing that I'm going to do is to label. Here is going to be A, so it means that this one is going to be A side. This one is going to be B, so it means that this side is going to be B. And finally, this angle is going to be C, so it means that this side is going to be C. Okay, so here we have something special. Here we have a 25 degrees angle, and this is 120. It looks like something weird, but it's 20. I'm going to write here with pencil. Okay, it looks better. It's 120 degrees. Okay, so remember that the addition of the internal angles of the triangles always is going to give you 180. So with this information, I can calculate this one, and I don't need to use any theorem to do it. Okay, just make a subtraction. 180 minus 120 minus 25, it's going to be 35. So it means that this angle is 35 degrees. Okay, so I have that information right now. So the question is, what I'm going to use now to calculate the side, the length side C and the length side B. Look at this. If you want to use cosine law, you need to have, if you want to calculate one side length, you need to have the other two sides. In that case, it's impossible because I just have one. So it means that in this number, in this letter B, I cannot use cosine law. I need to use sine law. Let's see. For example, for calculate, well, first of all, let's make over here. 6 is corresponded with the sine of 25. Right? This is corresponded with this. And then B will be correspondent with the sine of 120. There we go. So here, as you can see, well, this is 6 centimeters. We have only one unknown. All right, so the only thing that we need to do is just to clear. So we're going to move this one. This is going to be dividing, is going to pass how multiplying, and I'm going to say 6 centimeters times sine on 120 over sine of 25 degrees. It's equal to V. So it means that the length is going to be, let's do it, let's make 6 times sine of 120 over sine of 25, and this is going to be equal, well, in that case it's not equal, it's approximately equal to 12.29 centimeters. Okay, and I'm going to storage in one letter. I'm not going to use A, B, or C because I don't want that you're confused, so I'm going to use D. Remember, we used D in the last example, but it doesn't matter. So if you select another time D, the only thing that is going to happen is that this number is going to replace the other number that you have, okay, the other value. So just press AZ, then answer, then storage D. There we go. Let's check if we have it, and then we have it. So it means that this is going to be the value of T, that is, at the same time is the value of B, that is this side. Okay, now I'm going to use right now another time 6 centimeters over sine of 25, because it's the correspondent. Now will be correspondent of C over sine of the 35, that is the angle that is in front of. Okay, so right now the clear process is going to be this multiplying this 6 centimeters times sine of 35 over sine of 25, and this is going to be C. Okay, that I'm sure is going to be something approximately, because it's going to be an irrational number. Let's do it. 6 times sine of 35 over sine of 25. Okay, there we go. So this is going to be approximately 8.14 centimeters, and I'm going to storage on letter E. Okay, let's storage AZ, answer equal storage E. Let's check. There we go. Okay, so we have this one over here. So with that one, with that information, I have the 3 sides of the triangle, and then I can calculate the perimeter. That is going to be one side times the 2 sides times third side. Okay, length. And this is going to be equal to side A is 6 centimeters plus side B is D, my calculator, and side C is E on my calculator. Okay, so I'm going to use calculators. I'm going to say 6 plus alpha D plus alpha E. Okay, and this is going to be approximately equal to 25.43 centimeters, and this is going to be the perimeter of the triangle. I'm going to use it over here. Okay, and I'm going to continue with the other one. The last part is the area. The area is base times the height over 2. Okay, well, in that case, we are going to check which part is going to be the base, which part is going to be the height. I'm going to say that this is going to be the base. Okay, I'm going to write over here base, My question is, what is the height? The height, remember, should be the length from the top of the triangle, okay, in a straight line to the base in a perpendicular line, like that one. There we go. This is going to be the height, okay? And we don't have that data. We need to calculate it. And again, guess what? We need to use a right triangle. We have two options. This one or this one. Which one do you want to use? It's up to you. You have the information of both, so it doesn't matter. Okay? So let's suppose that we're going to use that one. And let me tell you why I prefer that one. Because I have this longitude exact. Okay? Whatever, if I use the other one, I have exact in my calculator like a E. So it doesn't matter. I'm going to reproduce it over here. Okay? This right triangle. This is going to be the hypotenuse, that is 6 centimeters. I have this angle, that is this one, is 35 degrees. And this part is the height. Again, which hypotenuse is that? Is the adjacent or the opposite? In that case, is the opposite hypotenuse. Okay, so which trigonometrical function we're gonna use? Sine, cosine, or tangent? In that case, we're going to use sine, because it's the relation between the opposite hypotenuse and hypotenuse. So we're gonna write sine of 35 degrees. It's equal to the opposite hypotenuse, that is the height, over the hypotenuse, that is going to be 6 centimeters. Okay, this one is going to pass multiplying, and we're going to say that the 6 centimeters times the sine of 35 degrees, it's equal to the height. So height is going to be, let's calculate it. Let's calculate over here. It's 6 times sine of 35. This is going to be approximately, let's write over here, approximately equal to 3.44 centimeters. And I'm going to storage it on, well, as you can see, I have DE. Now I'm going to use F. Okay, I'm going to storage AC, answer equal, storage F. Let's check alpha F. Yes, we have it. Okay, this is important information and I'm going to use. Good. Right now I'm going to calculate the area. Area, it's equal to base. Base in that case is B, that at the same time is D. Alright, so it's base times the height, that is H, that at the same time is F, my calculator, over 2. Okay, so area is going to be, let's do it, it's alpha V times alpha F over 2. There we go. We have approximately equal to 21.15 square centimeters. Remember the units, it's something very important that you need to put it. 21.15 square centimeters. Alright? And here we have the two examples about oblique triangles. Remember, the triangles are a very important thing or topic in the geometry because those are very useful in different ways. okay, and applications. And it's important to know what kind of theorems we need to use when we have a triangles. So that's why you need to identify if you are working with right triangles or oblique triangles. And as you can see in the examples, sometimes we can use both theorems about the right triangles and oblique triangles, because we can make or build implicit triangles that are not in the geometric shape that we are working with. This is all for today. Thank you very much for watching this video, and see you on the next class.